Veissmann's kind of your guys' go-to, right? It's kind of your guys' thing.
Yep.
So this is the last CM2 186 that they really made. I guess they stopped making them all together. So you guys got one of the last ones. But other than that, I mean, it's pretty standard. I'm sure you're used to seeing it. The intake air comes off of that louver over there. It comes up and goes over to there. The intake for the atmospheric boilers has a damper on it, so that enables it intake air first, the combustion air. But this is direct vented, so if you come in here and that thing's open, it shouldn't be open for this. Something might have went wrong, whatever. This has also been inspected, tested. You guys familiar with the Veissmann 300, which is the controller up top here? All right. I don't think I'll go too in depth for that, but it has heating curve. So you get a heating curve set point on here. I do want to specify is that the domestic hot water set point is not from this control. So if there's ever a problem where we have to, like, you want to up the water temperature or whatever, it's not through this, it's through the front end that we're providing. The front end, it was easier to do it with the pump strategy and all that through the front end, and we just give this a closure. So
hang on, sorry to interrupt. So I got to take readings, like PM readings,
Okay.
domestic and heat. So I just need to where I can take temperature readings and pressure readings.
Okay. So temperature for the domestic or the boiler water?
Both.
Okay. So this will tell you the boiler temperature right here.
Okay. And then pressure on the side over there?
Yeah, so the pressure's over here.
Yep, on the right. Yep, okay.
But this is a primary secondary loop, so you're gonna have kind of two different pressures. I'm not sure what they want on your PM. The fill pressure of the building, which is on the inlet side of the secondary pumps, is right on this station. This gauge right here. So if you're looking for just like a general building pressure,
Yeah.
but there's gauges on the primary sides of each one of these.
Yeah. Okay.
But if these pumps are running and those pumps are running, you're gonna get like a 5 or 10 pound difference between the two. It's just how the systems operate.
So what is controlling the temperature in the Turbomax? Where is that from?
So that's from the front end. And
What's that?
The front end's it's gonna be an address, like a website that you go to, and it'll show this building. It'll show all the alarms from this, and it'll have different inputs and graphics for the ERVs and stuff.
So it'll all be through the computer for those?
That's correct. So how these, what that does is all it's gonna do is close a contact on this boiler domestic hot water call. When this closure happens, this disables the outdoor air curve and goes right to 160 degrees. That way you don't have to run 160 degrees to the whole building. I'm sure you're familiar with that setup. That front end also controls the domestic hot water pump on the boiler side. So this is the pump station for the Turbomaxes. So these had to be controlled through the front end, so it was easier to have one system do it and swap it.
If the front end shit the bed, what we got to fix?
As far as just to get hot water all the time, you'd have to do this closure. So this relay, boiler domestic hot water call, I think it's 51. Their diagrams are not fantastic.
Because if it happened the same thing as Manny,
So you basically have to just close this relay. So domestic, they're labeled here. So boiler domestic hot water call. I think it's this one or this one, but you can just figure out where the wires go underneath this trough here.
Yeah.
And you just jump across it and you just get a good closure. And then that'll set this to 160 degrees no matter what. So you don't have an outdoor air curve anymore, but the building has heat and your domestic hot water will work. At least on the temperature wise. And then if you have to, in like an emergency situation, you'd have to, let me think about that, the pumps. So those pumps are 3-phase. For some reason, that's what they spec'd. We check rotation, everything works. But they have contactors in here for the actual motor starters. Are in this plate here. So in an emergency situation, you'd have to just get one pump on. So you'd have to bypass the contact, the motor starter, and just undo that and close that contact, you have 160 degree water through the whole building, and then you have one pump on all the time. So that'd be like an emergency, doesn't work. That's the easiest way to do it. There's no switch that we could do without re-engineering everything. That would just, like an override switch that I can really think of.
Yeah, because we were getting into that problem in another site. The computer's not good and we can't
You can't do
change it.
Right.
Can't do nothing with it.
Right. So that's, our phone numbers on the valve tag chart. You can call us even way on. And I built this whole room. I did the whole job as a foreman. So that would be the easiest way for this particular system. But we can always, our phone's always on. But that's the easiest way to get domestic hot water in 160 all the time. These pumps, and slow me down if there's something else you want to go on harder on. So these domestic hot water pumps are 3-speed, but they are speed selector behind this. So they're set for the highest speed. That's what they're balanced for. So these don't vary at all. They lead lag. There's a time clock for equal runtime on the front end that controls the two contactors. But that's really all these are. And if you ever have to operate these, keep in mind they are like say something breaks 5 years from now. Keep in mind they are 3-phase. You gotta check rotation. These are single phase. They can't really go backwards. You're familiar with these Grundfos pumps? Okay, these pumps are really, really good. So these you can enable without the front end in the case of an emergency. You just put pump. You go in the settings here. We have to do it for all. When we did temp heat and all that. You just go to pump state on and then constant pressure, and they just have their own DP station on them. And they should be set for 9.5 already. That's what we have them set for. But I'm not sure the failure scenario, if it might wipe it. So you get no power for 2 days or something. I don't know.
They lose internet sometimes.
Right. But these can be enabled from the interface here to just run. They won't care about any of the other stuff. They'll just run, and that will get you out of the building. So these two pumps do the whole building as far as all the baseboard, all the hydronic heat, are just these two pumps. Underneath these bags, there's check valves. Once our as-builts are approved, we have a full set of drawings that'll be here for how everything was built. It's a lot of information to just relay. But there's wafer checks in here. They're serviceable. They're flange style. So if you ever have a problem with them, you don't have to take the entire thing apart. You just take the rods out, slide them out, slide other ones in. You got a chem tank here. So for adding chemicals and stuff.
Did they do a water test on it?
Yeah. Everything came back pretty decent. We sent a gurney.
Yeah, that's what we use. Yeah.
I haven't seen the report, but my office should be taking care of that. So this mixing valve is the next thing we have to kind of like hammer home. So this is controlled. Yeah, I see. What's that face for? You like those? So this mixing valve is controlled by the front end. That's just the easiest way to do a floating style external mixing valve. So we have heating water return, cooler water. This is heating water supply after our close tees and all that. Basically, this floats on this sensor here to maintain an outdoor air curve. So in an instance where it's warmer outside, say it's 40 degrees, our outdoor air curve says we need 130 degree water for the building. But we have a domestic call that's going to bring the water up to 160 degrees. This will start stroking, mixing return water and 160 degree water to get off that sensor, whatever its outdoor air curve is, which is synonymous with the boilers. Two different programs, but they're programmed very close to the same. It's very hard to get a floating mixing valve to operate without doing an external, unfortunately. These are just butterfly valves essentially. So, been trending it, been watching it since we had it run about 6 months. Everything's been pretty tight, but again, everything's been different once everybody starts living in here. So,
Did you ask them why they didn't run everything off of the Vitatronic control?
we went through our ATC submittal. So House Corp did all this. I think it was just with the front end. I think it was easier to get the external control from their points versus the Vito. That's my answer. I don't, I just pulled this stuff together.
I know.
But really the only two things that the front end are going to have a lot of influence on are this and the domestic hot water. A lot of it came with lead lag for the pumps. A lot of that was a big driver of that. They only give you one pump output on those Vitos, I'm pretty sure, when we looked into it. Also similar for these, they wanted an external DP station, which we do have. And these pumps will ramp on that external DP. That's hard to do through a Vitodens. I'm not even sure if they have the logic input for that. But controls can go crazy wild. So there's only so much that I personally really know of. But this is important to understand. This is on that sensor. The valve chart is accurate, but I mean, it's going to say mixing valve on it. You know, you can only put so much on the chart. But this has its separate outdoor air curve from the boiler. They're programmed the same, though. That's the idea. So we have our closed T and air separator and stuff. So they had me put these big heat traps in. Was that enough for this? On this part, does anybody have any questions on that? Or
No.
okay. So